So welcome everyone to our current programming language lecture, and today we'll start talking about Go. Probably the simplest language of all we've talked in this course, one of the more practical languages, again used of course and developed by Google, widely in use, of course not the only one. So it's a practical language, it's a modern language, and we'll see what makes this language different from language such as Kotlin, which we looked at, maybe of course C++ or Python, some other language such as Java. Why did Google wanted to make this one? Actually, that's going to be the first question, right? So we'll talk about the background, the people who developed this language, and also we'll take a look again, of course, how you could actually do some work, right? We'll do a little tour today. Right, some basic features today, and on Thursday we will look at some more intermediate advanced features. There's really nothing really too advanced, unlike, for example, Rust or even Kotlin or even, not to mention C++. There's nothing really too complicated. Some things, you might say, some things are missing possibly. You might say, okay, some things I want, but they're not there, right? But again, it's people who use it. Again, we have some colleagues here who are not present today, who use them at work. Again, I also use it from time to time at work when I need to. Again, it's pleasant language, and the most thing, of course, is the ecosystem. Again, if you choose a language, it has good tooling behind it, right? So we'll explore it. So the story goes that this was developed by three guys. Well, three guys at the Google, but they're not really like three big, very important guys. Rob Pike, Ken Thompson. I'll show you the guys who they are. Ken Thompson, like famous graybeard, right? This guy here, yeah. He's like a wizard, basically, right? So he's almost now over 80 right now. So he actually invented B language, right? Not C, but B, right? He also was one of the main developers of original Unix. This means late 60s, right? This is going to be used Linux, of course, these days, but the Unix, the paradigms, the approaches are originated with him, basically. Of course, not only him, but also Dennis Ritchie. Well, Dennis Ritchie also Dennis Ritchie and some other important developers, right? So, yeah, so that's where he started working on Unix, right? So did he have Turing Award? Let's take a look. He should have Turing. Oh, he does have. Well, in '83, right? He was only 40 years old when he got Turing Award, right? So he also worked on chess, the chess programming, AI, of course, in 1980s, right? He's also guilty, but for UTF-8, part of a committee, right? So, all right. Well, actually, not guilty. Actually, it's a good thing, right? He was one of the developers of UTF-8 standard. Plan 9 for Bell Labs. You probably don't know about that one too much. It is actually sort of like a very influential operating system, but it's also free and open source, so you can try it out. But it was developed again in Bell Labs. Bell Labs is part of big sort of like again, a lot of money at the American phone company monopolies. He had a lot of money, just like we talked about Xerox had money coming in from the copiers. Dennis Ritchie was working at Bell Labs, which is doing research. Basically, they were doing research without any particular need to commercialize immediately, right? Of course, eventually, the money at these Bell Labs kind of run out. Well, they're shadow of it themselves these days, right? So, but anyway, so also grep, if you ever use grep, one of the tools at Linux, right? Of course, very important. So, and of course, Go, his last, and well, one of his many legacies will be the Go language, right? Of course, he didn't do it alone. These days, nobody does anything alone. There are two more guys out. Well, guys, Rob Pike. He is actually Rob Pike, also at Google. He's slightly younger. He's about 70 now, right? So he wrote a very famous programming book, the C programming language, late 70s, which is kind of de facto standard, right? So he also wrote some other books, right? He has some strong opinions. So he's what we call opinion leader, right? So many of his opinions transfer to Go, for better and worse, of course. Again, depending on your view, right? So that's his sort of contribution. And then there's a third guy, and let me see here if we can find the third guy from the Wikipedia. Let me see here, and I think his name was Robert Griesimer, right? looks a little bit younger, yeah. So only about 60 years old, right? So he probably did all the heavy lifting as far as programming goes, as developing goes. So, right. So, basically one of the sort of core contributors to the language. Of course, there are many more people coming into this language and development. So, again, so that was the background. So what was the problem with Google? Well, let me maybe let me write this down so we don't forget, right? Let's go to GitHub, so I can make a little new notebook for this. Some ideas. There's no programming languages. Maybe I have something already here. No, Go, Clojure. Right, I don't have anything here yet, so we will make it. Because I like this. I used to use Replit, but Replit now is not so good now for, so we'll use code spaces, which is great for development. So, I'll have to start. So there were things that, so what does Google have? Of course, it's a lot of computing going on, right? Indexing, search indexing, a lot of servers. So they had a couple problems. They had many C++ projects, and they had many Java projects. And again, if you've done any time you compile a large C++ or Java project, the problem is, of course, huge, large, long compile times. XKCD compiling, right? A famous early comic from XKCD, right? So it is a good excuse, right? So if you have an assignment, you say, okay, my project is compiling for half a day. Literally, yes. Project could be compiling for half a day. I mean, if you try to compile something like a web browser like Chromium or something, or even a Linux kernel, even a good machine, it can take half an hour, right? Maybe longer, right? Some larger projects that take a while, right? So this is one of the things that Go try to make your developer experience in general faster. Fast compile times, fast feedback, right? So again, also problems with dependency. What's dependency? You have something, you have depend on some other tooling, some libraries, right? And how do you manage everything together? C++ famously is very bad with this, right? There's no real standard package manager. There's no PyPy, right? Or NPM for JavaScript, right? So bad package management. So also parallel, Google does a lot of things in parallel, concurrently, right? So bad concurrency support, right? Also, of course, so the tooling also, right? So you could say, okay, why don't you use Python for everything? Well, Python has other problems, right? Python, of course, is famously dynamically typed, right? Loosely typed. You could say, well, dynamically typed at least. And also not fast, right? So they wanted something which is pretty fast, maybe not as fast as C++, would be nice, but, so that is the good design goals. Simplicity, fast compilation, good concurrency support, strong tooling, statistically typed and compiled, and memory them, and also, last but not least, you all love garbage management, memory management, right? You don't want to deal with allocating memory, right? Because it leads to if you can avoid it, right? Sometimes maybe you need to, right? So again, so all of this happened in late 2008, 2009, 2010. Right? So only about 15 years ago. This is a pretty new language, right? Pretty new language. So let's see what we have here. Okay, do I have to restart extensions? I might have to restart something. Yeah. All right, the Clojure. Okay, let's do reload, installing. I don't need that anymore, but we'll leave it. That's the reload window. Yeah. So, I talked about who did it. So Go 1 came out, I think, in 2012, apparently. Let's see, the Go development timeline. Go development timeline. I think around... Yeah, so this is actually, this is an official documentation, right? So, well, this is actually full release. So we now go 1.240, right? So with some minor revisions, right? So pretty far ahead. So I think Go 1 came out in 2012, I believe, right? So widely adopted in mid-2015. So again, why? Because of course Google. Right? If Google's using something and they're promoting it, right? It can't be all that bad, right? And again, of course, people like maybe emulate Google a little bit, right? That's also part of an issue, maybe, right? So, okay, now let me make a Google Golang project. Again, one of the choices they made, of course, the name. Again, what's in the name? Well, C is famously hard to Google for, right? So that's why you use C language. So that's again same problem with Go, right? I'm sure why they name it Go, because of course Google, right? They might not, it's obvious that Google and Go kind of nicely go together, right? Even though officially it's just something to go, right? Do it, right? But the issue, of course, is if you search for something like Go, you have to add programming or something, right? There's the issue, of course, Googleability or searchability of something is also important, right? JavaScript doesn't have this big problem, right? When let's say something like Kotlin, of course, doesn't have this problem because Kotlin is just a specific word. You don't really use it otherwise, right? But so, of course, as naming, you will see Golang. Golang is actually often called, right? So when somebody says about Golang, of course, they talk about Go, right? So now let me make a folder. So short history Go projects. I'll call this Go projects again, all right? Oh, and I'll make a little README maybe about this here. Yeah, let me make a README. README, yeah, or history MD, right? Let me see here. Let me add some. Let's use AI to write some things. Where's my open menu? I want to enable completions. Yeah. So Go programming language. Right? Oh yeah. History of Go. Right. Why was Go created? Right. And of course, this was, long compile times, right? Long compilation times, slow builds, right? So same, goes together. Control dependencies, unreadable code, right? Poor concurrency support. Those are kind of like, poor dependency, of course, and so on. Well, poor error handling again. So, well, again, this will get to this error handling again. I don't know how many have written Go before at all. Go has a very particular way of handling errors, right? Well, perceived poor error handling. Let's do this. Okay, let's leave it. Let's leave it at this, right? So, design goals. Who created Go? Okay, sure, we'll do these three people, right? Right, so I will do this by, all right, I'll do this. Come on, let's let the AI do all the dirty work for me, right? I'll just type it. Rob Pike, and of course, and lastly, but not leastly, right, Kent Epson, code at Google, right? At Google, right? Right, of course. Also, inventor involved in creation of Unix, B, and C, and grep, and I'll call plan B, plan, right? Oh yeah, and so on and so on and so on, right? So Rob Pike, of course, is also wrote textbooks. Yeah. Text. I don't know about him. Yeah, did he work on V8? Let's double check, right? Because do you know what V8 is? It's one of the first early JavaScript transpilers for Chrome. So let me double check if that's true. But Wikipedia says, is that true? Did he really work on V8? Maybe yes, he did work, right. So was he the actual inventor? Is that a guy? No, I think it's a different guy. This was a Danish guy. It was Lars Bak, that's the guy, right. Yes, he was the one who worked on V8. So again, different story. Again, you have to check with your sources. He worked on V8, but not, at Google. Right. So Rob Pike, again, let's double check on Rob Pike. Where's the Rob Pike guy? Right. And I forgot which books did he write. Yeah, the practice of programming, right. Yeah. And Windows first, some for 81. Okay, look at the system from 81, right. So first windowing system in 81, long time ago, right. So way before Windows, right. So Sam Acme, right, and I guess you also UTF-8. So again, UTF-8, right. So wrote the book practice, yeah. Did he work on first compiler? I don't want to say he worked on first compiler. That might be a little, right. Worked on Unix tools, tools, right, Plan 8. You work on Plan 8? Let's double check. Right, so they're probably, like I said, good friend. Yeah, Plan 8, UTF-8, yeah, okay. And so on, another thing. Okay, right. So, now let's go to design goals. So, yeah, when was it? So this is 8 to out, but yeah, a timeline of Go releases. Yeah, so something like this. We can check, right? I don't know if it's actually true. Let's see. So we should be now on 224. Let's see the naming, right? Let's double check the naming, all the releases, if it's true. Go release history, pre-go, right? So 2012 release 60, so 11, right? Naming was a little bit, so naming, yeah. So 2012 was correct, right? So this was 212. Well, not, yeah. So Go 11, yeah. So Go 1 was released in 2012. Go 1, yeah. So Go 1 was 2012 actually. Yeah. So let's double check, right? So 213, yeah, 213 is Go 1. So you see, you need to check the actual information, right? From, yeah. All right. Now, yeah. Now it's now 1, 2, 3, 4. So 1, 2, 4, 1.5 was 2015. 1.4 was the least. 1.4 was the 2014 actually. So that makes more sense. Let's double check. So 1.4, yeah, 1.5. So now it's 1.6, but again, they start diverging. So 1.4 is actually in 2025, right? So 1.4, right? Let's not get into this splitting. Yeah, to 2013, right, and so on. Right. On 2025, Go 1.25, right? Okay. Now, design goals. So design goals of what? Simplicity. What else? Fast compilation, right? Fast compilation. Garbage collection, of course. Concurrency. Did we mention concurrency? Of course. Good concurrency. Static typing. Memory safety, of course. That comes from garbage. And again, simplicity. We mentioned already simplicity. So memory management, right? Memory management with garbage collection. All right. So I think that basically is it. A strong tooling. Good, strong tooling. That's, of course. Cross compilation, right? Standard library. Again, yeah. Dependency management. Okay. Error handling. All right. Testing and so on and more. Add to profiling. Yes. All right. That's enough. Documentation. All right. Code formatting. Yes. Actually, good point too. Right. We'll talk about this too. Right. Code generation. No. Let's okay. So that was the idea. The goals. How well did it succeed? We will see, right? Oh yes, so we don't need this anymore, so we'll save it. Now, go history. All right, so we're almost. Now, of course, you want to say, okay, all this is all good, but how does it look? What does the language look like? All right, and we'll go to this our first page, right? Here, get started. Right, you can. So what do you need? Of course, so it is a compiled language. But unlike, for example, Kotlin or Clojure or, of course, Java or other languages, it doesn't use JVM. It has its own compiler, right? So what it does, it generates binaries. So that's a big thing. So what it means, you compile, you have a binary for your machine, particular machine. It could be Ubuntu, could be Windows, could be Mac, right? And you can run it without anything else. It's a compiled, just like C++, right? You don't need any other dependencies. You stick it in on your server and it runs. It's a big thing. So you don't have to worry about installing something else, some other dependency. Do you need a Java virtual machine? No. You run it. It's a binary. You give it to. If you know the machine type, of course, you have to know the architecture, but it will run. Obviously, you can run some other ways, but this is a big advantage because it simplifies deployment. So your challenge is writing things, right? But much easier, right, than deployment than many other languages, right? So it's one of the big kind of goals, right? So it's used primarily. Again, let me add this actually, right? Again, I can't. Okay, so usage, Go's usage. It is, of course, it's Go used by, of course, companies, but well, yeah, of course, Google and so on, but for what? Servers. So web servers, command line tools, desktop applications, to some extent. Okay, it read my words, right? And cloud service, of course. Networking again. So this, of course, all goes together. Machine learning, a little bit, I would say. Embedded systems again. Mobile applications, a little bit. I'd say a little bit, but not much, right? So WebAssembly, games, a little bit, right? A little bit. Okay. So again, cryptography, of course. Okay, and so on. Blockchain, of course. Yes. DevOps. Yes. Testing. Yes. Automation. Yes. Data processing, of course, and so on and so on and so on. Okay. Right. So that's all good. All right. Maybe a little bit on data analysis as well. Now, let's add a. Actually, let's get Hello World now going. Right? We all talked about how great it is, right? So if you go to here, it's actually in the links. Go.dev, right? Tor, on welcome. So let's expect this little Hello World. Right? Let me make this a little bigger. Right? So we have package main. So that looks like it's going to be a namespace, right? We do need to import something, right? Import format. And of course here we'll do, instead of doing the Chinese, I'll do Riga, right? We'll do Riga. Come on, where's my English? Riga. I don't have, Latvian. I need to use the left. Yeah, Riga. Okay, yeah, Riga. Right, and I can do emoji, right? So it should work. So full UTF-8 support. It would be a shame if you didn't support UTF-8, because the inventors of UTF-8 were working on this language, right? So again, and also notice in late 2000s, 2009-8, Python, well, still just making Python 3 was kind of coming out, right? So UTF-8 support was not so widespread among all languages, right? Of course, C++ does not have good UTF-8 support. It's a pain to use UTF-8 in C++, right? So this is a big thing again, right? Seems again, we take these things for granted these days, but yeah. Okay, so now it's going to compile, right? So let's see how we can, so hello Riga compiled, right? And we have binary. So let's see how about setting, let's set up this, right? Let's set up this, or let's see if we have Go already installed. Maybe it's already installed. So it should be, maybe if not, I'll have to install it. Go version, yeah, it's installed. So I really don't need to, if you had to install it, right? You can do manually. So let's do a new model. Let's do a new module, right? Let's do a little hello, and I'll go under Go projects. I'll do a hello project, right? Let's do that. So namespacing. So do hello project. Hello. I'll just do hello, right? Oh, sorry, hello. Yeah, right. So and I'll do, of course, I'll go here, right? I'll change the CD, Go projects, Go hello, right? And recommended is to actually Go mode init hello. I'll do myself. Let's see. GitHub com val RCS, right? Val RCS. This, of course, this is arbitrary, right? Hello. Let's see what happens, right? Yeah. So let's see. Yeah. Let's see this, right? We have Go mode, right? Let's see what's in Go mode. Let's double check. Yeah, it just says that it's a module. It's not really strictly necessary, right? So, but let's make a new file. Let's do main, of course, right? So I'll make a new file here, right? I'll do main Go, right? So this actually should work. So now, of course, yeah, Go extension from Go team at Google. Sure. Let's install the official installation. Again, by the way, yeah, trust Google. Well, as much as you can trust anybody these days, right? But there is, of course, you don't have to use the Visual Studio Code, right? There is a other option. There is a Go ID from JetBrains, and which I had actually installed on my computer. It's called Golang, not Go language, but Golang. So this would be your major alternative, right? If you like IntelliJ tooling, right, this is very good IDE. It's slightly heavier than Visual Studio Code, right? But has some extra things. It does have pricing, of course. If you're academic, if you're a student, it's free. You just need to sign up for the free account. But yeah, it's yearly. It's like 2,000. Sorry, 2,000. No, sorry, no. It's 250 euros at the moment, right? But again, for students, it's free, right? So, okay, right. So, but of course, you just need the Go compiler. So let's compile something, right? So let me make a, yeah. So we have our extension, we have our this, and let's do main, right? And the support. Now I'll just let completions open menu is. Oh no, it's actually so. Let's do a little. So package main, right? And of course import. We'll just do one for now. FMT, right? For now. And of course function main, func main, and we'll do print hello world, follow Riga, of course, again. So on we should be off to races, right? And not actually Riga. Okay. Now let's compile this whole thing, right? So go run, right? Go run main go. It works, right? So it works, right? So there's extension, right? Again, you can customize your environment, right? So let's double check what we have actually here. Do we have the compile? No, we don't have the actual. So go build, right? So let's do go build, right? Yeah. So we'll see if this works. I'm gonna try this. Let's see. Oh, it did work. Look at this here. So yeah. So go build worked. Again, what version is this again? It is 1234. So it's from last year. Okay. So hello, right? It's a binary. It works. So I can give it to somebody else, right? You compile it, great. So pretty easy to use. Again, you could do some other commands like so go build here. It worked because I think we set up this environment, right? As using this here, mod, right? This is not strictly maybe necessary. This namespace, right? Of course, is not strictly necessary, but I just say it's okay. It's under my, my project basically, right? So, okay. So hopefully this makes sense, right? Another simple Go example, right? Yeah. All right. Now, what else do we want to do? And so let's look. So we run off. Let's look at another short tour. We still have a few minutes. So go local. It's Latvian. You can translate in Latvian if you want. There's Ukrainian version, right? Korean, right? Simplified Chinese, and so on. And let's go to next one. Go offline, right? You can install, right? So installation, if you want, right? So Windows, Go version, right? I'm pretty sure we don't have one here. We kind of I would be shocked if we have one. Yeah, you see, you can't get any command. Yeah, actually, this administrator has turned off all the commands, so we can't do anything here, right? On Linux, it's simple, right? You can download the latest version. Mac, right? Mac is usually installed already. You can download also the Windows, right? So pretty easy. Now let's see, do we have any more Hello World? So go playground, right? So let's do some time again. I will do this. Welcome to the playground. All right. So same thing. Now, notice. So what we do here, right? Playground in Riga. Again. Riga. RBS, right? And for format and time. So again, package. Look at again. Of course, we have nice little. We used to Python as sport. Same thing also for Go. We have nice little documentation built in, right? It tells you what it does, right? It tells you, of course, very capable, like printf and scanf, right? So in many ways, it has many things you learn in your C++ part of the course. They will apply in Go, but they will be simpler. Also, what else we have? Look at it here. What's missing? What do we miss here again? Just like in Kotlin, we are missing semicolons, right? Because we hate typing semicolons, right? Again, simple thing. So print line, so format, again, from the library, again, namespace. So it's really big on namespacing, of course. So okay, it's come from format, right? Print line, right? You'll see, of course, there's ways of making it shorter, but this is just standard way of doing it. So now let me see build. Go build. Will it work? Will build by no mistakes. And let's run it. And yeah, it runs. Provides me this full time now, timeout 12:41, right? For some reason it thinks it's 12:41. That's probably because it thinks it's on Greenwich time, right? English, UK, British time, right? So, okay, so that's basic, very basic, right? Easy to build. We could compile directly. Yeah. So basically, idea was, yeah, go build. So if you, so I said go build. Let's add something else, right? Let's compile something else. It should work, right? So again, notice again we could do go run without compilations. Of course, obviously there's compilation step, but you don't save it. It's a temporary binary, but there's no binary behind, right? So again, let me read me this, right? So running Go. Running and building Go programs. Simple, right? So it's basically go run. Yep, that's what we do. On building Go programs, we use, of course, build Go, right? So we'll have a binary. This will build a binary. Yeah, in this case, main, right? So we could also, I think, provide a name. Of course, you could rename it afterwards if you want, right? So, and then you can use the binary, right? This binary can be run on any compatible, yeah, same computer architecture that the one you built on. Okay, so mixed up things. All right, so let's see the playground. Toro Go. Oh, actually, that's right. Yeah, instead of Go playground. All right, let's see one more. Right, Toro Go. Right. What let's do next lesson. No, we did that already. Okay, yeah. So we'll do that after the break. So let's take a short break. Let's continue at 2:50. Yeah. All right, so short break. So 2:50.